Hello, my name is Howie, and this is UBC Vulcan's team entry into the TMS Bladesmithing competition. I would like to first start off with a land acknowledgement. UBC Vulcan acknowledges that the land on which the University of British Columbia is situated on which UBC Vulcan has the opportunity to live, learn, and grow, and on which this project was accomplished is traditional, ancestral, and unceded territory of the Musqueam people. UBC Vulcan acknowledges that the land on which the 2024 bladesmithing competition is held on, which UBC Vulcan has the privilege of competing in, is the traditional territory of the Ayas, Alpachi, Calusa, Timucua, Tocobaco tribes, as well as the Seminole tribe of Florida and the Miccosukee tribe of Indians of Florida. Before we start forging, we have to make sure that our smiths are properly dressed with appropriate PPE. Steel-toed boots, leather aprons, non-flammable gloves, and face shields must be worn at all times while forging. Now moving on to the actual blade. UBC Vulcan has created a Tishone dagger, a Y-shaped dagger that is double-edged and single-beveled. This dagger is a common tool used by many indigenous peoples in Alaska and northwestern Canada. The tool was used for functional purposes, such as hunting and skinning, but was also used for ceremonial purposes. Although the tool is normally made out of copper, our team decided to use Damascus steel for the blade. However, we sourced many traditional materials for the handle: diamond willow and dull sheepswine, both of which are native to northwestern America, and sourced from traditional southern Tishone territory in Yukon, Canada. To create the blade, we first had to create the billet, and to do that, we welded together sheets of 1095 and 15N20 steels to form a steel sandwich. Although Damascus is normally made by repeatedly folding and then hammering the blade, our team found that there wasn't really a reliable way to fuse the sheets of metal together. The team did tests in the summer and found that, due to the sheets of metal not being able to properly fuse together, folding caused more delaminations. So our team went with a different technique that involved using a chisel. The billet will be welded normally, elongated, then a chisel will be used to make diagonal marks into the profile. After the patterns are created, the blade is then austenized at 900 degrees Celsius for around half an hour to prevent potential internal stresses from developing during the quenching process. The blade is then quenched in 50 degrees Celsius sunflower oil and lightly tempered at 205 degrees Celsius. We then took some metallography tests on the blade at each step, 2 after quenching and 2 after tempering, and then observed their grain sizes under 20, 40, and 50 times magnification. Overall, we found that the quenched samples featured larger needle-like microstructures compared to the tempered samples. The average grain size of the quenched samples was around 20 micrometers, and the average grain size for the tempered samples was around 29. This is mainly because the quenched sample contains more martensite, which forms needle-like microstructures, whereas the tempered sample has more tempered martensite. And this is our team's final result.